Chaos engineering versus load testing. This is delivery and operations, the part of system design that asks how your software behaves when things go wrong. Most people treat these two as the same practice. They are not.
Here is where almost every system actually sits today. Nobody on the team knows how it fails. Not because they are careless, because nobody has ever found out. There is a diagram. Every box is drawn, every arrow is labeled, and everybody has agreed that it is correct. And there are sentences people say in reviews. The retry will cover it. That call has a timeout. Those sentences have never been run. They were never written down, and they were never checked. So the first person who ever runs the experiment is a customer at 3 in the morning. And the failure gets to choose the time, and the part that breaks, and the size of the audience watching.
The subject today has a name: resilience testing. And the idea behind it is simple. Break your own system, deliberately, on a quiet Tuesday while you are sitting there watching it, instead of waiting for it to break by itself on the worst possible day. The area covers 3 things: load testing, where you drive traffic up a ramp and find out where the system bends; chaos engineering, where you break one part on purpose and check whether what you believed about it was actually true; and game days, where you rehearse the whole failure with people in the room. Now, what it is not. This is not unit tests, which check that your code is correct. It is not monitoring, which only watches. And it is not a post-mortem, which happens afterwards when it is already too late. Today is about the first 2, because they get confused with each other constantly.
So, are these not just the same test? Both of them break something on purpose. Picture a rope bridge across a gorge, wooden planks, and 4 ropes holding the whole thing up. The load test goes like this. The bridge is completely sound. Every rope is intact. Nothing is damaged. You walk 1 person onto it, then 10, then 50. You keep adding weight until the planks start to bow, and you write that number down. Now you know the weight limit. The chaos experiment asks a completely different question. 3 people are standing on the bridge, a perfectly normal Tuesday, ordinary weight, and you take a pair of cutters and you cut one of the 4 ropes, on purpose, because the drawing on the wall said that 3 ropes are enough to hold it. So now you find out whether the drawing was right. Same bridge. One of them is measuring capacity. The other one is auditing a belief.
Let us start with the cheaper and safer one and look at real code. A load test is a ramp and something you watch while it climbs. Here are the stages. 500 requests a second for 2 minutes. That one just warms the caches and fills the connection pools, so the first numbers are not garbage. Then 5,000 for 5 minutes, a busy but normal day. Then 50,000, which is the number somebody wrote down in the launch plan. Underneath that is a check for what counts as a healthy response, a success code, answered in under 400 milliseconds. And at the bottom, the numbers you actually record. Notice that it never records the average. An average hides everything interesting. It records the median. It records the slowest 1%. And it records saturation, how much of the processor, the memory, and the database connections are genuinely in use. Now read what is not in this file. Nothing is broken. Nothing is switched off. Every dependency is up and healthy. The only thing changing anywhere in this experiment is how much traffic arrives.
And this is what that ramp hands you. At 5,000 requests a second, the slowest 1% of requests is still flat, around 90 milliseconds. Everything is comfortable. Then somewhere around 8,000, that line bends upward. And that bend has a name. It is called the knee, and it is the real ceiling of this system. It is also almost never the number anybody guessed. There is always exactly one resource that ran out first, and that one resource decides everything that happens above the bend. Below the knee, doubling the traffic roughly doubles the work you get done. Above it, the waiting time climbs faster than the traffic does, because requests are now queuing behind whatever ran out. In practice, that is usually database connections. It is much rarely the processor, even though the processor is the thing most people watch.
Now the honest limit of all this, because a load test is not the whole story. A load test measures the system you have under the traffic you imagined. It answers one question, and it answers it very well. How much can this hold before it bends? But look again at what the experiment assumes. Everything inside it is healthy. That is not an oversight. That is the definition. You cannot measure a ceiling while the floor is falling in. And real traffic is lumpier than a neat staircase. It tends to arrive all at once, in bursts, rather than spread out evenly. So a load test can hand you a ceiling. It can tell you nothing at all about what happens when a part of the system dies.
So here is the other one. Same system, opposite variable. The traffic stays at a normal Tuesday. Exactly one thing changes. And look at the first thing in the file. It is not code, it is a sentence. The hypothesis. If the payments call gets 300 milliseconds slower, checkout still answers in under 1 second because that call has a timeout and a fallback. That sentence is the entire experiment. Underneath it is the steady state, a small function that says what healthy looks like right now, and it is measured before you touch anything, not afterwards. More than 40 orders a minute and checkout answering in under a second for the slowest 1%. And then the fault itself. Add 300 milliseconds of delay to the payment service. And look carefully at that last line. Share 0.05, 5% of the calls, not all of them. That single number is the difference between an experiment and an incident.
And here is the part that almost everybody gets backwards. A load test validates your capacity plan. A chaos experiment validates your beliefs. Those are not the same thing at all, and the beliefs are what actually takes systems down. A system can pass a ramp at 10 times its real traffic, comfortably, with room to spare, and still go down completely the following week. Not because it ran out of room. It goes down because one service that nobody ever called critical got slow, and something upstream had no idea what to do about that. Volume was never the thing that was wrong. An assumption was. And the assumptions are exactly the part that no test in your pipeline has ever executed.
So what is a chaos experiment actually testing? Take any architecture diagram and read it as a list of claims that nobody has ever run. On the left, what the diagram says. That call has a timeout. The retry will cover a short blip. The fallback serves cache data. Losing search only degrades the page. All 4 of those are completely reasonable, and all 4 of them are beliefs. On the right is what happens when somebody finally executes them. The timeout turns out to be on connecting, not on reading, so it never fires on a slow answer. The retry has low pause built into it, so it triples the load on a service that is already struggling. The cache warms itself from the service that is down, and search is waited for before the page renders, so losing it does not degrade the page at all, it stops it. Each one of those is a single experiment away from being a fact, and not one of them shows up in a load test, because in a load test, nothing is broken.
Which brings us to the part that separates an experiment from an outage, the runner. First line, before touching anything at all, check the steady state. Is this system genuinely healthy right now? If it is not, stop, because if it is already limping, you will learn nothing, and you will turn a bad morning into a worse one. Then apply the fault, and there's that 5% again. That is the blast radius, and it is a number you choose deliberately. Then the loop. Every second, recheck the steady state. The moment it stops holding, stop the experiment. That is the abort button, and it has to be automatic, because a human watching a graph is far too slow. And then the most important word in the whole file. Finally, remove the fault. Always, even if the runner itself crashes halfway through. Without that line, you have not run an experiment. You have injected a permanent fault into production and walked away from it.
And then the result, which is never neutral. If the hypothesis is disproved, that is the good outcome. That is genuinely the point of the exercise. On the left, what you walk away with, a belief that is now a fact, a bug found at 2 in the afternoon instead of 3 in the morning, and a limit that you chose rather than one you discovered. On the right, the things that turned out never to have been true. That call has a timeout. The retry is harmless. Search is optional. The fallback was tested. It degrades, it does not break. We would notice within minutes. Every one of those crossed out lines was sitting in somebody's head this morning, and if nobody had run the experiment, they would have been in the postmortem instead.
Now the honest part, because neither of these is free and they are expensive in completely opposite ways. Load testing is cheap and it is safe. You run it off to the side and nothing real breaks. But the traffic shape is one you invented, and real traffic is lumpier than anything you would sit down and write. It also only exercises the paths somebody thought to script, never the strange ones that real users find. A clean ramp is evidence about volume and about nothing else. Chaos engineering is the opposite. It is worth nothing at all until you can actually watch the result, because you cannot limit damage that you cannot see. It needs a written hypothesis,
a small share of traffic, and a working abort. Without all three, it is simply an outage that you scheduled. And it needs an organization that will accept a deliberate failure during working hours, which is why it is usually the last practice a team adopts and almost never the first.
So, the line worth remembering. One of them measures the ceiling, the other measures the floor. Load testing, a healthy system, rising traffic, and the question is, how much does this hold? Chaos, normal traffic, one part broken on purpose, and the question is whether the damage stayed where you believed it would. They are not two stages of one practice. You do not graduate from one into the other. They answer genuinely different questions, and passing one of them tells you almost nothing about the other. And the uncomfortable part is that most systems running in production today have measured neither. They have only ever measured an average Tuesday, and an average Tuesday is the one day that was never going to take you down. One concept all the way down to the code, every single time. If that changed how you read your own architecture diagram, hit like and subscribe.